moving on from caching, I'm moving to the next layer, which is what are the tuning levers in Websphere application server. Like I said, right, WCS is just another Java application running on VAS. So having the application container properly optimized will just improve your performance. So a few things are very important, right? First is your web container, right? Every request coming in from the web server to your JVM is assigned a thread from the web container thread pool, right? So, there used to be a belief that, set this web container thread pool to a very high number of threads because it would improve throughput and the ability to handle a lot of concurrent users. That's simply not true, right? Because if you have too many web container threads, each CPU, would be dealing with a large number of requests. There will be context switching, etc., than actually doing the job, right? So we need to arrive at the min and max of web container threads in a very iterative fashion, right? It depends on a lot of factors. How many CPUs do you have in your in your bots? How many are they dual core, quad core, are they single core, right? I mean, do they even have hyper-threading? A lot of these would also play a role, right? In the past we have set the values around 25 to 30 containers, 25 to 30 threads as a limit per JVM, and this has worked out well. Setting it to something like 60, 70 and all will just make your CPU run very, very hard and will not give you the value. You'll just see so much queuing. So, I would say start off with 5 threads per processor, right? 5 threads per, if you have 8 CPUs, right? Start off with 40, but assuming you have 2 JVMs, it will be 20 each, and then keep iteratively tuning to arrive at that sweet spot, right? It's a balancing act. So web container, we talked about web container, most important thread pool because that's the one that is actually doing your job. The next one is your Websphere, WCS ORP connection pool. Important only if you're doing a lot of remote requests using RMI. Default values like 50/50, I believe. You can set it to anything higher just based on how you communicate to your how much requests do you need through an RMI call. Just make sure this doesn't become a bottleneck, because if this becomes a bottleneck and you won't even realize, you will think that your thread is slow, but it's actually getting all accumulated here. So unlike the next one is the database connection pool, right? Your JDBC connection pool. Unlike the web container thread pool, right, where it needs to be a very iterative activity, this one is something that you can actually calculate, right? It needs to be a minimum of, it needs to be at a bare minimal equal to your web container pool. So if you have 25 threads or 30 threads, then set your database connection pool to min of 30. The other advantage we have seen is, right, keep the min and max active. The way it works is, right, when your server starts, your connections are not warmed up. When your server starts, your connections are not warmed up. But as they get used, your connections are warmed up. But if you set the min value to low, it will again get cleaned up. So it will not just go below the min values, but setting the min value to be the same of max value and make sure that your connections always remain, so that all your subsequent requests will not have to undergo that extra connection cost, right? The other couple of other things that we have valued a lot is warm up your JDBC connection pools, right? As you start your server, JVMs, just warm the connection pools, right? Don't let for them to actually, lazily accumulate, right? That improves performance. The other big, performance gain that you can get, especially in Oracle rack architecture, is, let's say you have a 6-node Oracle, rack. Rack is a, real application cluster. 6 separate Oracle database servers, right? Divide your JVMs and hard bind them to each of their nodes, right? That will make sure that all threads on all JDBC connections from your JVM will talk to a particular node, right? It will not disturb the other nodes. Otherwise, right, there's a lot of cost in the database spent on context switching from node to node. So introducing that DB node affinity has clearly helped performance. So the next one is, so we talked of, continuing on web, application, tier or app container tuning, right? The next one is like prepare statement cache. a lot of people know that, right? When you have a JDBC connections, you can cache a lot of JDB statements so that they're all precompiled and they don't need to be compiled again, right? There's no magic formula to arrive at the size. But the good approach is the first thing I would suggest is profile the SQL trace. When you load the page, see how many SQLs are being fired, and just make sure your cache is enough large above that, right? The other aspect I forgot to talk about is, right, Websphere has a very good, PMI or performance monitoring infrastructure. So if you go to the WAF admin console, you can configure a lot of these metrics, and when you do a load test, it will give you a real-time, metric view into, how is the cache, prepared statement cache being used, how many web container threads are used, how many are idle, are you spending a lot of time in, JDBC connections, acquiring all this, you'll get that view, right? And then finally, your JVM, right? We talked about what you can do with Websphere application server. Then coming to the underlying JVM, right? The main thing in a JVM is the heap size. I mean, heap size, will hit your garbage collection behavior. We have seen that your heap value of roughly anywhere between 1 and 1.5 is good. Your heap might be slightly, you need to make sure your heap accounts for Dynacache if you're not using an external in-memory grid, right? So otherwise 1.5 GB is pretty good. The only trick is, let's say you're running a 32-bit JVM, right? You have 2 power 32 or 4 GB of space for the process, right? You divide the 4 GB into 1.5 GB for the heap, and then the remaining 2.5 GB for your native memory, right? If you set the heap higher than 1 and say go to 2, the only problem we've seen is, right, when garbage collections doesn't kick off for a long time, and when it kicks off, right, it tries to collect a lot of memory, a lot of objects, so you will see GC pauses, right? GC pause is extremely nasty because when the pause happens, your CPU just falls down to 0, right? And you really can't do anything. So make sure that your heap size is a balance between how frequent garbage collection runs, and at the same time ensure that there is no GC pause, right? The preferred garbage collection policy, for Websphere Commerce, my recommendation is GenCon, because GenCon creates separate areas, right? Like a nursery area for all your short-lived objects, and then your tenured area for your long-living objects. So if you heap, you could probably say somewhere between 350 to 400 MB can be kept for nursery, and the remaining for the tenured area. So that kind of concludes the Websphere application server level tuning. So moving on quickly to core frame.